Thank you for joining me today as we discuss a new era in the Bell Performance product line, a new formulation for X-tra Lube Concentrate that we feel accomplishes a very difficult task, that of making the old X-tra Lube formulation even better. And once we're done today, and once you learn everything about what the new formulation has to offer, we think that you are really going to like it. I am Eric Bjornstad. I'm the Technical Information Director with Bell Performance. And so what we're going to talk about today is we're going to talk about the transition from the old X-tra Lube formulation to the new X-tra Lube formulation. Of course, we will talk about the features of the new formulation, and we will cover how it compares to the old. How is it better? And if you are familiar with the old formulation, if you have spent years using it and you're used to its quality, then news of this transition might not be something you want to hear. But by the time we're done today, we are confident that you will come to the same conclusion that we did, that the new X-tra Lube formulation, with everything that it has to offer, is going to not only meet your needs in the lubrication field, but exceed the performance and the benefits of the old X-tra Lube formulation. So to start with, we talk about the traditional X-tra Lube Concentrate formulation that was formulated with what we called MBL. MBL stands for metal-based lubricant, and it was formulated in the early 1980s by Dr. Chris Clausen. And its unique value proposition has always centered on the action of its MBL backbone, which contained copper and lead particles, both of those very malleable and slippery metals, so to speak. And when used in any lubricating oil formulation, they would fill in surface wear and surface imperfections on metallic lubricating surfaces. And they would really do an excellent job of reducing friction and supplementing the lubricity of the oil. And then in addition to this, the traditional X-tra Lube lubricant formulation has always had an additional additive package that adds other value points to the product. It always contained detergent, dispersant, anti-foam, and now these kinds of things were already present in the oil's base additive package. When you buy a finished oil, those things come with the oil. However, the supplemental additive package that the X-tra Lube Concentrate contained would supplement and extend this protection for the oil. And so we sold this X-tra Lube formulation for a number of decades, since the early 1980s. So when we talk about the fact that it has been reformulated and changed, obviously there is a reason why this had to be done. So when we talk about why it had to be done, there's a number of reasons. So let's talk a little bit about those so that you have some context as to why the transition had to happen. First one was constituent costs, most directly for the base metals that are used in the MBL formulation, the cost of which had gone up precipitously in recent years. When you're talking about manufacturing costs and equipment, on the manufacturing end, the X-tra Lube product was one of the most expensive and had the highest overhead of any product that we manufactured. When you look at manufacturing times and capacity, it also took a pretty long time to manufacture, and given that we always aim to be able to provide high volumes of the product for international markets, it became apparent that a transition to a different formulation would enable us to keep doing that. And then price competitiveness, of course. Even though the performance of the X-tra Lube products was superior to virtually anything else out there, when you talk about the sheer cost of the constituents and the overhead and the time needed to manufacture them, it meant that the old X-tra Lube formulations simply had become not cost competitive in the B2B marketplace. Now, typically, what you would say when you talk about things like manufacturing times and equipment and capacity, typically the solution to that is to look for a toll manufacturing provider, of which there are many of those. However, because of the uniqueness of the MBL package, the fact that it contained unique constituents like copper and lead that weren't normally used in other inferior lubricants, it was virtually impossible for us to find a toll manufacturing partner. And so that was one of the reasons that played into the decision to transition to a different formulation. And then the last one, regulatory concerns. Over the years, the United States EPA has been putting pressure on lubricant manufacturers and formulators to limit the presence of elements like sulfur and phosphorus content in lubricating oils. And this regulatory trend led to speculation and concerns about possible limits being imposed on other metallic content like copper and lead, which would then eventually force the reformulation of MBL anyway. So all of these factors made it evident that we needed to reformulate the products and replace them with new formulations. If we could not successfully do that, then we were going to have to drop the X-tra Lube line altogether, which is definitely something that we did not want to do. But it was looking like we were going to have to make a choice because we had passed the tipping point where the total cost of manufacturing and keeping X-tra Lube in the product line was more expensive than the tangible value that we could get from keeping the products in our line in their formulated states. So we began the search for the best alternative. Now, anytime you're talking about reformulating something, you have some goals that you're looking for. And we knew that there had always been a very high level of expectation from the users with regards to the quality and the performance of the X-tra Lube line. And so any replacement that we were going to find needed to be a really high quality replacement. And when you're asking, well, what defines high quality replacement? Well, we had a list of essential characteristics. Most importantly, it had to offer market-leading performance. There would be no point in having a replacement if it was just like one of the standard off-the-shelf lubricants that you could get anywhere. There wouldn't be any point to having that. So, most importantly, it had to be market-leading performance. Secondly, it had to be easier and more cost-effective to manufacture. The new formulations wouldn't do us any good if we couldn't produce them in a more efficient and cost-effective manner. This is especially important for if you are going to engage in a toll manufacturing situation, which has always been a possibility. It needed to be something that they could formulate as well if we decided to go that route. So easier and more cost-effective to manufacture was also an essential, important consideration. So this brings us to the new formulations for X-tra Lube oil treatment. Which is to say that we wouldn't be having this discussion if we had not found a replacement formula that, in our view, satisfies these essential criteria that we had to have in a replacement. So let's talk about the two new replacement formulations, one for lubricating oil and one for grease. X-tra Lube Concentrate for lubricating oil, X-tra Lube Grease, for grease. Now, on this session, we're really only going to talk about the concentrate. We have another training session presentation on the X-tra Lube Grease, which will go into more depth about the specifications and the features and benefits of the new X-tra Lube Grease. So for this one, we really want to concentrate on the oil treatment, X-tra Lube Concentrate. So we need to understand what the difference is between the new X-tra Lube and the old X-tra Lube. Only then can we know how to explain the formula transition and how to communicate the value points of the new X-tra Lube product. So taking a step back, we have to ask ourselves, what made X-tra Lube great? Another way to put it would be, what set it apart in the marketplace? The obvious answer here is the MBL additive package formulation. In the MBL, you had the copper and lead particles, and they really gave X-tra Lube a unique ability to fill in wear on metal surfaces. And this, of course, gave the user a very high quality, what they call EP, or extreme pressure protection. Really enhanced the lubricating oil in that manner. It also gave them really superior residual protection as well, should their lubrication fail. Unfortunately, as discussed earlier, the unique features of MBL provided by the copper and lead were also one of the drivers one of the driving reasons why a reformulation was needed. So now we have a new formulation backbone for X-tra Lube, and the new formulation backbone is calcium sulfonate. In a nutshell, calcium sulfonate provides a broad range of attractive benefits in lubricating situations. We're talking about a very good extreme pressure and anti-wear protection, just like the old copper and lead base in the MBL. Also provides corrosion protection for those metal surfaces. It provides detergency. In other words, it helps to clean those metal surfaces and remove the byproducts that tend to build up in lubricating situations. And if they're not removed, they have the potential to harm lubricated surfaces. So it has very good detergency in that respect. And also acid neutralization. Calcium sulfonate has proven to be an excellent acid neutralizer. And again, in these in typical lubricating situations, you would always have the potential for formation of damaging acids, and calcium sulfonate actually does an excellent job of neutralizing those. So you take these four main benefits together, and you have a suitable replacement for the benefits provided by the old X-tra Lube formulation. Now, calcium sulfonate itself, you may also hear it referred to as calcite. And calcium sulfonate has actually been used in the lubricant field since probably the 1960s. So we're talking about a good 5 decades or so. It has been used since the 1970s to provide anti-corrosion and rust protection in lubricants. So it has a long history of doing that very effectively. Then in the 1980s, they started incorporating calcium sulfonate into lubricants and greases as an EP agent, as an anti-wear agent, which is what primarily it's used for in X-tra Lube Concentrate. So calcium sulfonate has a well-established history in the lubricating field as a valuable component. So what changed to get us from the older formulations with MBL to what we have today? I mean, if it's so good, why didn't we make the switch before? Well, partially because we didn't have to, because the MBL was working so well and didn't have those other, shall we say, outside pressures had not come to a tipping point yet. But also because calcium sulfonate has not always been as high quality in the past as it is now. In order to understand this concept, we have to see what calcium sulfonate actually is. Calcium sulfonate is a particle that provides protection in lubricants, but not in the same way that the MBL particles did. Now, for lubricants, anytime that you're talking about adding something to supplement a lubricant, and if that thing is a particle like calcium sulfonate is, then particle size has always been critical to performance, and not just to performance, but also to clarity in oil applications. And in years past, calcium sulfonate manufacturing methods would tend to yield sulfonate with a size that was about 200 to 250 nanometers in size. Now, that may seem kind of small, but for the use of putting it into oil lubricants, it really wasn't an optimal size. In fact, that kind of particle size created inherent limitations to both the solubility of the calcium sulfonate and also the appearance as well. The lubricating chemists or tribologists had challenges in being, when they added calcium sulfonate to a base lubricating oil, it was difficult for them to get it to stay in solution. It was difficult for them also to be able to get that oil to be clear instead of cloudy. And oil users do not like using cloudy oils. So the challenge for industrial chemists was to create or manufacture a calcite formulation that had small enough particles that the solubility and the clarity in oil would be high enough or would be satisfactory for the lubricant marketplace. Now, what has happened is that there have been new synthesizing technologies that have been developed over the last few years that have been able to produce calcium sulfonate particles much, much smaller. Instead of 200 to 250 nanometers in size, you're actually talking about 50 to 80 nanometers, even possibly down to 10 to 15 nanometers if you're talking about what they call amorphous particle sizes. In other words, they don't control the sizes and distributions. They can get them really small, but they're not of uniform shape. That kind of a calcium sulfonate particle is great for use in a grease application, but you don't really want amorphous or non-uniform particles in a lubricant formulation. So the breakthrough happened when they were able to make uniform calcium sulfonate particles that were 50 to 80 nanometers in size, which is, if you do the math, that's about a 70% reduction in size from the old 200 to 250 size. Now you've got a case where the calcium sulfonate particles that are produced today are small enough that their solubility and their clarity in lubricating oils is markedly improved, and that makes them ideal for use in the new X-tra Lube formulations. So with the new particle sizes, how does the new formulation compare with the old one? Now, we're not talking here about old calcium sulfonate versus new calcium sulfonate. Now we're talking about the old MBL, the copper and lead particles, compared to the new calcium sulfonate particles. Now, the reason we bring this up is because traditionally in the old X-tra Lube Concentrate, the MBL formulation was traditionally marketed and its value propositions were communicated by talking about the copper and lead particles and their sizes. Typically 3 to 5 microns in size, which is pretty small. And the reason why that was brought up was because they had to be small enough to pass through the oil filters. Because if the particles are too big, the oil filters would just catch them and they wouldn't be able to do their jobs. So 3 to 5 microns traditionally were small enough to enable them to pass through most conventional oil filters of the time. Although, in practice, when you had the manufacturing process for X-tra Lube would actually, agglomerate or make some of them stick together, and so you would get a distribution of particle sizes ranging from 3 to 5 microns to, 20 to 40 microns, depending on, the randomness of the process. Now you have switching to calcite gives you particles of uniform size 50 to 80 nanometers. Now, when you're comparing 50 to 80 nanometers versus 3 to 5 microns, a human hair is about 50 to 100 microns in thickness, as you can see on your screen. You've got other things like, mold spores are 2 to 10 microns. Bacterium can be 1 to 3 microns. Pollen grains can be 10 to 20 microns. Those are just some examples. Now, when you're comparing nanometers to microns, there's actually 1,000 nanometers in 1 micron. So if you have a 50 nanometer size particle of calcium sulfonate, that is actually 1/100th the size of a 5 micron MBL particle. And this is a significant difference when you're talking about certain benefits that you need in the X-tra Lube Concentrate oil treatments. Now, you recall that in terms of when you're asking how does calcium sulfonate work, we've already discussed how the MBL worked. We've already reminded you of how the copper and the lead particles change shape and they fill in the surface irregularities and they provide excellent extreme pressure protection. The calcium sulfonate component in the new X-tra Lube formulation works by a little bit different mechanism that's related to the concept of boundary lubrication. When you get elevated pressure and you get elevated temperatures, just like the ones that you normally get let's say in an engine environment or in a lubrication environment, when you get elevated pressure and temperature, the calcite actually will react on the metal surface and it will form a layer of protection that tribologists would call a boundary layer. And so if you have one layer on one metal surface and one layer on the other, and then you have the oil film or the lubricant film in between. And so what happens is that the two protective layers of calcium sulfonate actually combine, in effect, to increase the strength and increase the protection of the oil film or of the lubricant film. And so what that does, in effect, is it makes the lubricating film stronger and better able to protect the metal surfaces at higher and higher pressures. This boundary lubrication mechanism is the same protective mechanism that was used traditionally by ZDDP, which was, for many years, the most widely used EP additive for oil, really in the last half century. Except that calcite doesn't have phosphorus in it like ZDDP has, and if you know anything about oil formulations, like let's say you have an older car, you might know that the EPA has pushed over the last decade or so, has really pushed oil formulators, lubricating oil formulators, to reduce ZDDP content in the motor oil because of the phosphorus's effects possibly on catalytic converters. So the calcium sulfonate in the new X-tra Lube Concentrate essentially provides the same kind of protection that ZDDP used to in the older or lubricating oil formulations. Now, let's compare and look at specifications, performance specifications here between the old X-tra Lube oil additive and the new X-tra Lube oil additive. And just for reference, we'll also throw in just an anonymous aftermarket oil treatment, something that we'll call alternative oil additive. So you see a number of things here on the screen. You see load wear index, you see some things related to scar size and last non-seizure load in kilograms and weld load. What you see there is test data for the ASTM D2783 test. It's called the 4-ball wear test, and it is one of the standard tests for documenting EP wear protection of lubricants. So this is how the new X-tra Lube formulation compares to the old ones. As you can see, you've got load wear index, and you've got scar size, last non-seizure load, and weld load. Now, what do those mean? Well, in order to understand what they mean, you have to understand how this test is being run. What you've got when you're running a 4-ball wear test is you have a special apparatus that has an arm that has some bearings in it, and you put a specified amount of lubricant in a holding chamber, and then you put 3 bearings in it, and then you bring 1 bearing down on top. So you've got 4 balls that are rotating against each other because the machine is going to rotate them in a circular fashion. And then you're going to start applying defined kilograms of pressure essentially intervals of pressure that are increasing over time. And the rationale is that the better the lubricant, the better it will protect as you increase those pressures. Eventually, what will happen is that you'll start to get scars that are being formed, and eventually, those scars will get bigger and bigger as the loads increase. And then eventually they'll become so large that the pressure will become so large that the lubricant fails. So on this test, what you see last non-seizure load here. Last non-seizure load is defined as the last load under which the wear scar does not increase by 5% over the baseline. Another way of thinking about it is it's the last load, or it's the point at which the wear will start to accelerate, and that gives you an indication that the lubricant may be starting to lose protection. The last column here, weld load. Weld load is the load at which the balls welded together. And then these two here, the two scar measurements, last non-seizure and last seizure scar measurements in millimeters, these are the sizes of the scars right before the wear really starts to increase. In other words, the size of the scar at this point, and then the size of the scar right before the weld load, this point. So, and then last one, the load wear index. Load wear index is a mathematical computation of the total protection over the entire spectrum of the test. In other words, they take all of the scar sizes from the smallest measurements all the way up to the largest measurements, and they come out with this load wear index. The higher load wear index is, the better. So when you compare the results, you can see that the old X-tra Lube, the MBL-based X-tra Lube formulation, does have the smallest scar size set, and 0.38 millimeters compared to 0.45 and 0.41, and 2.38 millimeters for the last seizure scar versus 2.7 and 3.06. So this is good, as we would expect it to be. It also has a higher weld load, 250 kilograms compared to 200 and 250. So those are good results. And if those were the only things that you needed to concentrate on, then you might conclude that, comparing this formulation to this one, you might conclude that the new X-tra Lube is an inferior formulation. But hold on, those aren't the only things you need to concentrate on. Note that the last non-seizure load, this measurement here, is higher for the new formulation than it is for the old formulation. 120 kilograms for the new, 80 for the old. What that tells us is that the new X-tra Lube does a better job of protecting and reducing friction in what we would call the medium range area of pressure, which one could argue is the most important area. It's kind of like if you are an American football fan and you know about quarterbacks throwing the ball. Someone could say that one quarterback can throw the ball 80 yards. But most football analysts would say, well, that's nice, but it's most important for them to do really well in the middle areas, in the 15 to 20-yard passes. And that is, that's the mark of a most effective quarterback, and that is the mark of a more effective additive, is not necessarily how high it can go, although high is good, all of the things being equal, but it's not the most important thing. The most important thing is this area here and this area here, the load wear index. As you can see, the new X-tra Lube formulation with calcite outperforms in total lubricating protection to the old X-tra Lube formulation with MBL. So even though it doesn't quite reach a 250 kilogram weld point, these figures overall should indicate to us that the new X-tra Lube formulation does an excellent job at enhancing the oil's anti-wear properties. Now, other benefits that it brings. It keeps metal surfaces clean from deposits, and it neutralizes harmful acids to protect against corrosion. Even before the calcium sulfonate technology was refined to allow ever smaller calcite particles to be produced, calcium sulfonate was used in lubricants as both a detergent and an anti-corrosion protectant. In any lubricating situation, it's very important to keep metal surfaces clean and keep them free and protected from dirt and sludge molecules that may form in the lubricating environment. It's also extremely important to keep them protected from damaging acids that are inevitably produced over time. So the active ingredient base in the new X-tra Lube Concentrate, the calcium sulfonate base, it does turn out actually to be a multifunction package, because not only does it provide the protection, the lubricating protection we talked about here, but it also cleans the metal surfaces to protect them from damaging deposits, and it scavenges acids that are produced in the high pressure and high temperature environments. So with respect to extreme pressure or EP protection and detergency, the new X-tra Lube formulation offers both of those benefits, just the same as the old one does. But we think that it does actually a better job in both respects. And it has a couple of additional inherent advantages that those who have used the old X-tra Lube formulation and those who have experience in using it, they will recognize that what we're about to talk about is actually a significant and really important upgrade here, and we think that it makes it even more improved product. What we're talking about is settling and filter plugging. Now, one of the unavoidable problems with the old X-tra Lube formulation, with the copper and lead particles, one of the unavoidable problems was it had a tendency to settle over time, and it had potential filter plugging issues. That's because the metal particles were heavy enough that they could not stay homogeneously suspended in the oil for long periods of time. They would eventually start to settle out to the bottom. When we would ship drums of product to other countries, to the Far East, we would typically ship them in 55-gallon drum volume with 45 gallons of product, and the users of the product would then need to mix the product once they got it to get the MBL particles redistributed and redispersed back into the formulation. And then when you're talking about filter plugging, that was becoming an increasing concern in recent years because of the move towards smaller and more efficient oil filters on vehicles. The new common rail diesel engines had oil filters that were filtering out 1 to 3 micron particles, and that really created a potential for possible filter plugging when you use X-tra Lube. Now, those problems are no more. The new X-tra Lube formulation, first of all, remains homogeneous in storage with no discernible settling problems. And the 50 to 80 nanometer calcite particles, they're considerably smaller than even the smallest dirt and contaminant particles that might have to be filtered out by today's high-performance oil filters, which means you're not going to have potential filter plugging problems like you might have had before. As for proper handling guidelines of the product, proper handling of the new X-tra Lube Concentrate is pretty simple. You can add it straight to the engine if you want. You do not need to immediately run the engine in the same way that you had to before. The only difference of note between the new and the old with respect to handling and application is recommended temperature. Now, the new formulation of X-tra Lube is a little bit thicker than it was before. Under normal ambient temperatures, this is not a problem. You can dispense it into your, out of the bottle. If you buy it in a bottle package, you can pour it out of the bottle without a problem. Those who are using it in colder winter climates, it's going to be recommended for them to have a drum warmer or to keep it stored at in kind of an ambient room temperature so that it does not become overly thick. And then for people who are purchasing it and then blending it or doing bulk treatment, we recommend that they heat it up to between 176 and 194 degrees Fahrenheit. However, that's really only going to be for a limited number of users. For most people, the handling is not going to be an issue if you store it at ambient temperature. As you know, when you're looking at the old MBL X-tra Lube versions, traditionally we had 4 versions of the MBL-based product. We had Concentrate, X-tra Lube Concentrate. We had X-tra Lube Premix. We had X-tra Lube Trucker's Best, which was formulated with the right amount of X-tra Lube to treat a larger oil capacity, such as in a long-haul trucking situation. And there was an X-tra Lube One-Shot. Reformulating the product enabled us to reassess our sales strategy with respect to what we wanted to offer, and after looking at everything, we are streamlining everything to just one product version, the simple, straight X-tra Lube Concentrate. It will initially be available in 8-ounce bottles and 55-gallon drums only. We feel that eliminating some of the lower volume product versions will simplify us and enable us to shift our efforts into offering a more quality product. So, given how X-tra Lube Concentrate has been improved in a number of key ways over the old version, we think that anyone who has used the old MBL X-tra Lube Concentrate, once they try the new formulation, they're going to see that it provides the same level of outstanding protection while also providing those other benefits that we think is really going to make it, bottom line, a more superior and more valuable oil treatment than even the old X-tra Lube was. So if you have any questions about this, you can reach me at the Bell office. You can send me an email. Again, I'm Eric Bjornstad with Bell Performance. I hope that we've been able to show you just how great the new X-tra Lube formulation is going to be. And we are very confident that once you try it, you will never want to go back. So thanks very much for joining me. Hope this has been helpful. If you are looking for the X-tra Lube grease training presentation, we've also got that one as well. And if you've used the old X-tra Lube grease, then we highly encourage you to check out the training presentation and product presentation for the new X-tra Lube grease reformulation. So anyway, thanks very much for joining me, and we'll see you next time.